Hello there. So for today we will look into problem solving involving property of wave. So basically this one you should be able to relate with chapter 9 lah. Okay. So basically you will have continuation of chapter 9 but with a little bit of addition to the equation. Okay. So let us look into example 10.1. Okay. So example 10.1 you have a progressive wave represented by the equation given y as a function of x and t. Okay, so previous we only relate with one function only. Okay, but now over here you have two functions which will be x and t. Okay, so the equation is given as 2 sine pi t minus pi x. Okay, where y and x are given in centimeter and t in second. Okay, so for question A, they wanted to determine the angular frequency, wavelength, period, okay, the frequency and the wave speed. So basically this one you can obtain by comparing the equation lah with general equation. Okay, so later we will look into the solution later. Okay, and then sketch the displacement against distance graph for progressive wave in a range given, okay, x from 0 to lambda. Okay, so 0 to lambda, that means you will end up with one complete oscillation lah. Okay, one lambda which will one complete oscillation, and then time given as 0, and then for C they want it to repeat but the time given as 0.5 period. Okay, and then sketch the displacement against time graph for the particle. Okay, now this time you have x given as 0 and then the range is from 0 to capital T, where the capital T will be the period lah. Okay, also for one complete oscillation, and then E, sketch the displacement against time graph for particle. X now is given as 0.5 lambda. Okay, let us look into the solution. Okay, so first one what we do is that we compare with general equation. Okay, so general equation you will have A sine omega t minus kx. Okay, so straight away by comparing, okay, omega will be equivalent to pi radian per second lah. Okay, angular frequency, and then k will be equivalent to, okay, also pi, okay, per centimeter. And then we know is that k is equivalent to 2 pi over lambda. So from there we can calculate the value of lambda, which will be 2 centimeter. Okay, and then for the period of the motion, okay, from omega we can calculate the period, okay, where omega will be equivalent to 2 pi over t. Now over here omega given as pi, so therefore period we will end up with 2 seconds. Okay, the frequency of the wave. So we already determined the period. Okay, from there we can determine the value of frequency, which will be 0.5 Hertz. Okay, and then for the wavelength, for the speed of the wave, okay, V is equivalent to F lambda. Frequency we already determined. Okay, lambda we already determined. So just calculate the final value. Okay, which will be equivalent to 1 times 10 to the power of negative 2 meter per second. Okay, for question B, t is 0, they wanted to draw a equation. Okay, displacement as a function of distance x. Okay, so we replace in the value of t0. Okay, that means pi t. So pi times with value 0, we simplify the equation. Okay, that means we will end up with 2 sine negative pi x. Okay, so the negative sign you can put it in front. Okay, then what we do is that once we have the equation, we need to sketch a graph for. Okay, so the range is given until 0 until lambda. Okay, so the graph will start with negative amplitude lah. Okay, so the amplitude is given as 2 and negative 2, and then we just sketch for one oscillation only. So from the previous calculation we know lambda is given as 2, right? Okay, so for one oscillation the value of the length will be 2 centimeter. Okay, Okay, and then for period now is 0.5. Okay, so from calculation we know period is 2 seconds. Okay, so applying in, therefore t will be equivalent to 1 second. Okay, so replace in the equation. Okay, that means we will end up with negative pi x plus pi. Okay, that means when you have value of plus pi over here, that means we will have initial phase which doesn't start with 0. Okay, so this one over here, you have an initial phase which doesn't start with 0 lah over here, this value over here. Okay, so this one, that means you will have a starting point over here. Okay, so okay, so for plotting the graph, okay, we will have a positive amplitude, okay, shifted by half wavelength. Or what you can do is that you can plot, use the say first graph, okay, and then what you can do is that you can shift it, okay, shift it by half wavelength, okay, because initial phase we have pi, that means half wavelength, so that means we shift the axis by half, okay, which will be lambda over 2. Okay, so the wave propagate toward the right, so that means the axis we shift it to the left, so that means your starting point over here, the position will shift over here and then it will start from here, okay, and then over here. Okay, and then we redraw the graph lah, okay, for the new axis. Okay, if the wave is to the left, okay, and then the axis shift to the right, and then if the wave is moving to the right, then the axis we shift it to the left over here, the rule that you need to follow lah, okay, for shifting the axis. Okay, and then for d, x is given as 0, okay, so replace in, then determine the equation, okay, so you'll end up with 2 sine pi t, okay, so plot the graph, okay, amplitude will be 2 and negative 2, okay, with no initial phase, so you will start with 0 lah, okay, you start from 0, so you have one complete oscillation over here, okay, the range is given for one complete oscillation. Okay, and then when x is given as 0.5 lambda, so lambda is 2, so therefore x will be equivalent to 1, okay, so replace in, so that means you will end up with pi t minus with pi, okay, or rearrange, you will get negative 2 sine pi t lah, okay, because you will have a initial phase over here, okay, which will be a lambda, okay, half oscillation. Okay, so the first solution, we just redraw the graph, okay, based on the initial angle, okay, or initial phase. Another thing is that what you can do is that you can use the shifting method, okay. So you shift it by half a oscillation, so your starting point will start from over here, okay. So that means you will start from, okay, so and for the final solution, what we do is that we redraw the graph, okay, with the correct axis, okay. So label, so the drawing will be for one complete oscillation lah, okay. So the rule that applies over here is still the same. If the wave is moving to the left, you shift the y-axis to the right, and then if the wave is moving to the right, you shift the y-axis to the left over here, okay. Alright, for example 10.2, okay, we have a y versus x graph, okay. So over here we have figure 10.9 shows the displacement y against distance x graph. Okay, after time t for the progressive wave which propagates to the right, okay, with a speed given of 50 centimeter per second. Okay, over here they wanted to determine the wave number and frequency of the wave. Okay, and then B, they want you to write the expression of displacement as a function of x and t for the wave above. So basically we can obtain some basic information from this graph, okay, which will be the amplitude over here, which will be 3, okay, the maximum displacement, okay, you will get a 3 over here. And then for one complete oscillation, okay, so we have displacement 3 and one complete oscillation, you will end up with 1 centimeter, right? Okay, so this 1 centimeter will represent the length of one complete oscillation. That means it will be equivalent to lambda, okay, wavelength. Okay, so now problem solving, the information obtained from graph, okay, from the question we have V given, okay, and then from the graph we have lambda. Okay, so from value of lambda, we can calculate the value of k, which will be equivalent to 2 pi over lambda. So k, you will end up with 200 pi per meter. Okay. And then by using equation V equivalent to lambda f, okay, we can determine the value of frequency, which will be 50 Hertz. Okay, and then by using the general equation A sine omega t minus kx, okay. So what we can do is that we can replace in the value, okay, omega will be equivalent to 2 pi f, okay, so 2 pi f over here, and then minus kx, okay, we already determined over here, okay, so just replace in and then simplify the equation to obtain the final value. So over here, y and x in meter and t will be in second, okay. Okay, so for example 10.3, you have a sinusoidal wave traveling in the positive x direction to the right. Okay, amplitude given as 15 cm and then wavelength is 10 cm and frequency is given as 20 Hertz. Okay, at t is equivalent to 0, a particle at x equivalent to 0 has a displacement of 15 centimeter. Okay, so that means it does not exactly start at equilibrium, right? So that means you will have a initial phase over here, 15 centimeter. Okay, so they want you to write the function, wave function, x and t, the function of, and then determine the speed and acceleration when given t 5 seconds for the particle on the wave located at 5.0 centimeter. Okay, so information given, you have amplitude, okay, wavelength, lambda, and then frequency is given. Okay, so given y at x0 and t0 is 15 centimeter. So this one will be the initial position. So what we can do is that we can use it to determine the initial phase. Okay. So the wave number given, okay, based on the lambda, we can calculate the wave number and then the angular frequency. Okay. So okay, you will end up with 0.2 pi per centimeter and omega 40 pi radian per second. Okay, applying the general equation. So replace in the value, so we'll end up with 15. Okay, so that means amplitude also given as 15, so that means sine phi will be equivalent to 1. That means the initial phase lah. Okay, so that means your initial phase will be equivalent to pi over 2 radian, which will be 90 degrees. Okay, so therefore rearrange and then replace in the value, you will end up with the final equation lah. Okay, so where y and x in centimeter and t will be in second. Okay, and then to determine the speed of the particle. So for determine the value of speed of the particle, we have to differentiate lah. Okay, differentiate function y towards t. Okay, so this is the initial function. So differentiate towards t. So that means you will end up with a omega in front over here. Okay, so a omega multiply with a and omega, you will end up with 600 pi lah. Okay, function of sine will become as a function of cos over here. Okay, so inside the bracket you will still have the same value lah. Okay, So once you have the equation, replace in the value lah. Okay, so you're given with x 5 and t is 0.5. Okay, so replace in the value. So the final answer you can end up with 0 centimeter per second. Okay, and then for the acceleration, we have to differentiate velocity toward time. Okay, so cos you will end up with negative sign. Okay, so initially we have 600 pi. Okay, times with another 40 pi. Okay, so you will have 24,000. Okay, pi square. Okay, so once we have the equation ready, replace in the value of x and t. Okay, to determine the final answer. So which will end up with 24,000 pi square centimeter per second square. Okay, so for next subtopic, it will involve superposition of wave. Okay, so this one we have example 10.4. You have two harmonic wave represented by the equation below. Okay, you have wave y1. Okay, 3 sine pi t plus pi x, and then you have y2 3 sine pi t minus yx. Okay, so basically you have two different sign convention over here. That means these two waves have the same amount of amplitude. Okay, and other characteristics are same. The only difference is that the direction. Okay, one is moving in the positive direction, another one is moving in the negative direction. Okay, so moving to the left and then moving to the right, but these two waves are moving towards each other. Okay, so they wanted to write the expression for the new wave when the both waves are superimposed and then determine the amplitude. Okay, so this one can refer back at the notes. Okay, so the final wave which will end up with twice the amplitude. Okay, y will be equivalent to twice the amplitude, that means 6. Okay, pi x sine pi t. Okay, so that will be your new expression for the superimposed wave lah. Okay, and then y and x in centimeter, t in second. Okay, from the new expression, the new amplitude will be equivalent to 6 centimeter. Okay, and example 10.5, you have a stationary wave represented by the following expression. Okay, 5 cos pi x sine pi t, where y and x in centimeter and t in second. They wanted to determine the three smallest value of x. Okay, where x will be greater than 0, that correspond to node and antinode. Okay, so node will be the line or point where you will have minimum value. Okay, so node means null. Okay, none, not available. Where antinode you will get maximum value. And then B, they wanted to calculate amplitude of a particle at given location lah. Okay, x 0.4, 1.2 and 2.3. Okay, so first we will look into calculation of node first. Okay, okay, so we compare the value where k is equivalent to pi. Okay, so therefore lambda will be equivalent to 2 centimeter. Okay, so when we have node, that means particle with minimum displacement. Okay, y will be equivalent to 0. Okay, so over here we are just going to determine the location of x, right? So that means we take the first part only. Okay, 5 cos pi x. Okay, so which will end up with 0. So therefore pi x will be equivalent to inverted value of cos 0. Okay, so which will end up with pi over 2, 3 pi over 2, 5 pi over 2. Okay, and then by comparing, okay, so that means in terms of x it will be 0.5, 1.5 and 2.5 centimeter. Okay, or x will be equivalent to, if you rearrange in terms of n, okay, n over 4 times 5, where n will be 1, 3 and 5. Okay, so that means if you just replace n over here, so that means you will end up with n 1 over 4 pi, okay, 3 over 4 pi and then 5 over 4, not pi, lambda. Okay, this one we try to compare with the above over here lah. Okay, for the value of the x in terms of lambda. Okay, next one, anti-knot. That means you will get a maximum displacement where y will be equivalent to 5, which will be equivalent to the amplitude. Okay, so the condition for you to get maximum is that when angle is 0, okay, pi, 2 pi, 3 pi, and so on lah. Okay, so therefore x will be equivalent to 1, 2, and 3. Okay, so in terms of order, m will be 0, 1, 2, 3. So therefore x will be equivalent to 1, 2, 3 centimeter lah. Okay, and then last one, the value x given as 0.4, so just replace in over here, so which will end up with 1.55 centimeter. Number 2, 1.2, so determine the amplitude, which will be negative 4.05 centimeter. And then number 3, okay, x given 2.3, so which will end up with amplitude 2.94 centimeter. Okay, so for example 10.6, you have an equation of a stationary wave given by the expression below. Y is equivalent to 8 cos 2 pi x sine pi t, where y and x are in centimeter and t in second. Okay, sketch a graph of displacement y against distance x. Okay, and t given as 0.25 period. Okay, for a range of 0 until lambda. Okay, so that means one complete oscillation lah. So by comparing, okay, we know k is equivalent to 2 pi. Okay, so therefore lambda is equivalent to 1 centimeter, and then omega given pi radian. Okay, so therefore period will be 2 seconds. Okay, so replace in the value. Okay, particle in the stationary wave correspond to anti-knot. Okay, so this one to determine the anti-knot position. Okay, when lambda is equivalent to 1 cm, so you will get the anti-knot at 0, okay, 0.5 centimeter and also 1 centimeter. And for knot, okay, n over 4, where n will be equivalent to 135, okay, lambda 1 centimeter, so that means you will get a knot at 0.25 and also 0.75 centimeter. Okay, the displacement point x equivalent to 0, okay, at t is equivalent to 0.25 period, okay, 0.5 second. Okay, so that means replace in over here. So therefore you will end up with y is equivalent to 8 centimeter. Okay, so that means for displacement versus graph, so initial point you will start with an anti-knot which will be equivalent to 8. Okay, so your first knot you will have 0.25, and then second point will be anti-knot which will be 0.5, then third point knot which will be equivalent to 0.75, and then the last point which will be a anti-knot. Okay, you will get 1.0, so which will be equivalent to one complete oscillation, which will be equivalent to lambda. Okay, so that's all for the first two subtopic. Okay, have a nice day. Thank you.